What's poppin', dogs? Mr. Allen here, solving for some missing sides of right triangles in this video. And we've got a few ways to solve right triangles. So we got to figure out which way we're going to use. And it's based off of the information that we're given. In both of these triangles, I have a known angle and I have a known side. This means that I'm going to be using right triangle trigonometry. So I'm going to want to write down a little SOHCAHTOA action right now, just so I have it up here. So S-O-H, that's for sine, which is opposite over hypotenuse. CAH, that's cosine, which is adjacent over hypotenuse. And then TOA for tangent, which is opposite over adjacent. All right, so we use that acronym there to remind ourselves of it. So why didn't I pick like Pythagoras or special right triangles? Well, for special right triangles, it is going to be, we're going to know some stuff about angles and sides, but it needs to be either 30, 60, 90 or 45, 45, 90. And these two angles are definitely not that. Now for Pythag, it's if I know two sides and I want the third side. I only have one side here and an angle, which means I got to use trigonometry, which also means I'm definitely going to need this bad boy. Bust that one out right now. And before we forget, let's put this thing in degree mode. So let's hit mode, and then you're going to arrow down twice and to the right once. It defaults to radian mode, which has its place in mathematics, but we want degree mode because our angles are given to us in degrees, not radians, all right? So now I'm in degree mode. I can hit second mode to quit back to the home screen. We're ready to rock and roll with this thing once it comes time to plug things into the calculator. All right, so for this first one, with respect to my known angle, which is 42 degrees, what are my other sides? I like to label my triangle opposite, adjacent, hypotenuse anytime I try to tackle one of these problems. So across from the angle here, right, opposite the angle, that is my opposite side. So OPP, yeah, you know me. The A, which is next to the angle, touching the angle, that is my adjacent side. So that's adjacent. And always across from my right angle, that is my hypotenuse. Okay? Across from the biggest angle, the 90-degree angle, it's the most hyped up side. All right, so let's set up a trig equation here. Well, what do we want to use? Sine, cosine, tangent. Like, how do you choose this? Well, let's say this. I'm gonna go for my adjacent side first. Okay, it's the letter A. It comes alphabetically before B. I'll solve for that one. So I want my adjacent. I have my hypotenuse. That means I'm gonna use cosine. Okay, so cosine of my angle, which is 42 degrees. 42 degrees. We could throw the degree in there in parentheses. You don't have to necessarily write that. Okay, I'm going to write it in there. Sometimes I might forget. But it is in degrees. Those are my units. And it's my adjacent, which is A, over my hypotenuse, which is 18 feet. Okay? I'm not even going to put units there. I feel like the units actually might muddy the situation up, especially when you're dealing with like feet and stuff like that. Just don't worry about it. All right, so now I need to solve this thing. How do I solve it? How do I get A alone? Well, since I'm dividing by 18, to undo that, I will multiply both sides by 18. But it all starts with that initial setup. You have to pick the proper trig function that goes with the situation which you're trying to solve. And now I have 18 times the cosine of 42 degrees equals A. So I've got A alone. I can literally just type that into my calculator right now, especially because I have it in degree mode, right? Remember, if you're not in that degree mode like we have right here on the third line over to the right, make sure you are. If you forgot when we first did it, make sure you're in there. Otherwise, you're going to get a crazy answer. But now I can just hit 18 times cosine of 42. Boom. 13.376. This does say to 2 decimal places. So I'm going to say A equals approximately, that's what the squiggly equals means, is approximately 13.376, so 38. Okay, so 13.38 units are in feet for this one. Definitely include the units in your final answer. Cool. So now I got options, right? I could, if I've got 2 known sides, I could Pythag my way out of this one to get B, or I could just do some more trig. And since I'm working with trig right now, I'm going to do this one with trig again, but then we'll also show it with Pythag because I do think it's kind of cool how it still works out the same, different math, but the same answer, all right? So I'll use orange for this one. Now I want my opposite. I have my hypotenuse. I'm still going to use my hypotenuse because it's my given measurement rather than this guy, just in case I made some kind of mistake. So I have sine this time because I want my opposite. I have my hypotenuse. Sine's the move. So sine of 42 degrees equals my opposite B over my hypotenuse, which is 18. And you'll notice I didn't put the degree marking in there. It's whatever. It's the work. It's the work. It's not a huge deal with this trig type of stuff. Whereas when you're doing like areas and volumes and stuff, very good idea to keep track of your units throughout here. It's just a quick couple steps. So 18s cancel, same algebra. And you might be like, can I just plug in 18 sine of 42 or like rewrite it? Absolutely. All right. And I'm going to get B right now when I do that. Now check this out. You could, if you want to be, bougie, hit this. I can arrow over in front of the sign. This is actually probably more work now that I think of it. Boom, sine of 42. Or you could just type in this, sine of 42, and be kind of normal about it. Who's going to think to arrow up? I don't know why. I just felt like do a little calculator flex for you. All right, so we get 12.0443. So 12.04 is my answer here for B. So B equals 12.04 feet. Boom. Excellent. Awesome. All right, so now I'm going to show you guys how you can actually use Pythag to get that B side there, or vice versa, whichever one you solve for first, and you'll still get the same answer. It's kind of cool. So make sure that we are using the unrounded values, the ones that are in your calculator there, right? The most decimal places, right? Because you only round once. Otherwise, your answer will be slightly off potentially with however many calculations you do. So the first one I solved for was A, and that is one of my legs, right? So it's going to be 13 point, and it was 376 squared. That's how I like to write it. So I'm like, hey, that's a calculator or a value I have in my calculator right now. Make sure I use that one. Use the one that's in the calculator that has all those decimals. That's the move. All right. Plus B squared equals 18 squared. And I don't really have the room to do all the algebra, but we're going to subtract that guy over. So let's type this into our calculator right now. I've got 18 squared minus, and now check this out. I can arrow up and grab my 13.376. That's where I would definitely do the arrow up and grab it. Squared, hit enter, and then we're going to square root that. So second square root, I arrowed up, enter it in, boom, we get 12.04. Look at that. The exact same decimals. Because this one ends in a 9-1, that guy ends in a 9-1. Now, imagine if I did this, 18 squared minus, and I just did 13.38 squared. Let's see how close it is. Because sometimes it's kind of close, but not always. Okay, so square root it. Whoa. Square root, arrow up, copy that in. So I still get 12.04. The numbers after are a little bit different, as you see. So wouldn't have made a difference on your final answer for this one for 2 decimal places, but does have the potential to impact things. If you round and calculate, round and calculate, round and calculate, better off round once at the very end. Yo, row. That's why I got a shirt. Okay, next one here. Let's see. So I've got one angle, which is 63 degrees. What are my other sides here? Well, opposite that is this guy's right here, OPP. Yeah, you know me. Across my right angle is always my hypotenuse. It's the longest side. It's hyped to do that. Hyped to be that, rather. And then next to the angle, touching the angle, but not my hypotenuse, is my adjacent side. So adjacent. I've got my triangle labeled, and now I can start picking out my proper trig functions that will pair up with these, okay? So let's see here. Let's solve for the adjacent side, okay? We'll do that first. Alphabetically, it's B, then C. That's how I stay organized. So I want my adjacent. I have my opposite. Boom. Opposite and adjacent. Tangent. Tangent is the move here. I don't want too similar of a color. I guess I'll use pink. We got tangent of 63 equals my opposite, which is 11.3, divided by B. Boom. Ooh. My variable's in the bottom, in the denominator on this one. That's unfortunate, right? It is kind of unfortunate because the algebra is going to be a little bit trickier, but no fear. We're good. We're good. We got this. I'm going to multiply both sides by B, and now I have the B's cancel over here, and I'm left with B times the tangent of 63 equals 11.3. Now, kind of hard to understand when you're first doing trigs. Sine, cosine, tangent seems so foreign, like what the heck is this, dude? But tangent of 63, that's just a number, okay? Oops, let me arrow down here. Tangent 63, it's just a number. So I have B times a number. How do I get B by itself? I would divide by that number, right? So on here, what I'm going to do is I'm going to show all that without typing anything else into my calculator. I don't want to write down any of my decimals, right? Because I want to save everything in there. keep everything as accurate as possible. And now I can type in 11.3 divided by tangent of 63 all at once. And there we go. There's my side. B equals 5.757, so 76. 5, squiggly equals 5.76. And we are in feet. Boom. Awesome. Okay. There we go. Now, got to solve my last one here, and we'll call it a day on this video, as I know it's gotten a little lengthy here, solving for all these sides, getting intrigued with it, but hopefully you guys have enjoyed it, okay? This guy down here, we got the hypotenuse. Hypotenuse. I was given my opposite. I want my hypotenuse. That means that we're going to use sine to solve this one, okay? I'm going to do it over here, get my face out of the way, all right? Because I don't have a ton of room right now. I've used quite a bit of real estate up here. So we have sine of 63 equals, my opposite side is 11.3. My hypotenuse, I do not know, right? So that's why I picked sine right there, because it's opposite over hypotenuse. Those are the two pieces of information that I have and want. So that's the one I'm going to use. All right, we're going to multiply by c on both sides. The algebra is actually the same here, and you'll start to notice some of these patterns and be like, oh, can I just do 11.3 divided by sine of 63? Absolutely. However, I would be careful with that, because you start to fall into certain traps. You think something's the same every single time, and then all of a sudden you make some kind of a careless mistake. So be careful with that, all right? We're going to divide by sine of 63. We're going to plug this bad boy all in our calculator at once. Sine 63. Let's do it. So I have 11.3 divided by sine of 63, 12.68. So starting in green, C equals 12.682, so 68. Oops. Feet. Almost forgot my squiggly equals. Not the end of the world if you don't use the squiggly equals. We use those to say it's been a rounded answer. That should be kind of implied when you're using trigonometry, that they are going to be rounded answers. That is a terrible, terrible 8. I apologize for how awful that 8 looks. I don't know if that's any better. But there we go, guys. That's a lot of stuff there. A lot of stuff in trigonometry. I love trigonometry. It's really cool. It seems like mathematical magic to me, where it's like all of a sudden spits out this number. And you can actually you can use this in real life and find a length. I do it all the time when I'm building stuff. If I have an angle and I got to find a length that I got to work with, I use trigonometry. I bust out the TI on the job site, and boom, we can make our cuts. Everything fits nicely. So very cool, very powerful stuff. Hopefully you guys enjoy trig just as much as I do, and have a wonderful day. Thanks for watching.